Hey y'all, today we are going to be talking about factoring again, but this is factoring polynomials at using the special cases that we learned when we were multiplying. Alright, so let's just review the special cases first, the way we have been using them before we go backwards. So type 1 was the product of, so multiplication of a sum and a difference, where the first terms are the same and the last terms are the same. And the second is when you are squaring a binomial. So the first and the last are the same, but both are addition or subtraction. So for type 1, we know that the outer and the inner cancels out. So to find the shortcut, to find the answer once you multiply them, the shortcut is you square the first, you square the last, and it's a difference because b times the opposite of b is minus. So you square the first, and you subtract from that the square of the second. With type 2, this time the outer and the inner are exactly the same, so you double it. So this shortcut is you square the first, and you square the last. You can take these two middle terms, multiply them by each other, but then you have to double it to keep track of that outer and the inner. So you square the first, you square the last, you take these two terms multiplied by each other and then double that. So negative 16x. And that's the shortcut that will get us to our trinomial or binomial. So for this lesson we're going to be going from here backwards. From here and backwards. Alright, so let's do type 1 first. Remember when you multiply, it looks like this. So it ends up like this once we multiply them all out. So we're going to be going from this to this. So you have to decide if it fits, if the problem fits the type 1. So I have some conditions set up for you. It's like a checklist. If it fits all of the conditions, then it works. So you're going to look at each problem. Is it a binomial? So you come up here, is it a binomial? Yes, check, that works. Does it contain a subtraction sign? It does, so yes, check, that works. And are both terms perfect squares? In this case, they are. So we have to know that we can separate it into this. And again, this is just one of those things that you just have to know. Use the checklist to help you to see if it is a type 1, but you just have to know it. You have to memorize it. So let's do a few problems. So I'm going to use the checklist. Let's look at this problem right here. Is it a binomial? Check. Does it contain a subtraction sign? Check. Are both terms perfect squares? Well, 16x squared is a perfect square and y squared is a perfect square. So to get our factored form, which we know is going to be two binomials multiplied, one is going to be addition, one is going to be subtraction, you take the square, let me move that out a little bit, you take the square root of the first term to undo that squaring process, and you take the square root of the second to undo that. So we have 4x plus y times 4x minus y. And we can double check it. 4x times 4x is 16x squared. That would cancel out. The outer and the inner would cancel out, and this would be our y squared. So this would be your answer. Alright, let's do the one right below it. Is it a binomial? Check. Does it contain a subtraction sign? No, it does not. So it does not fit the type 1. We can't work backwards to get this. We could still possibly factor out a common binomial like we were doing prior to this, but they don't have anything in common. So we have to just say, it is prime. We can't factor it. Alright, let's go to this example right here. Is it a binomial? Check. Does it contain a subtraction sign? Check. Are both terms perfect squares? Well, let's look at this. 9 is a perfect square. The square root of 9 is 3. The square root of x to the fourth is x squared, and the square root of y squared is y. So that's a perfect square, and we know b squared is a perfect square. So those are my first and last terms, and I just have to write them as two binomials, one with a sum and one with a difference. And again, now this is my answer. We can't do anything else with it because all we're doing right now is practicing our factoring skills. All right, and the last example on this page, little tricky because it looks like it has an addition sign. But look at this right here. Remember, we can reverse. So I could write this 4x squared y minus 36. So be very careful with this. Now it's a binomial. It does contain a subtraction, and they're both perfect squares. So we can do 2x y plus 6 times 2x y minus 6. All right, similar to type 1, type 2 has a checklist as well. So this is what it looks like if the problem says to multiply, like the last part of the unit. But this is what your original problem is going to look like if it asks you to factor, like this part. And you're going to write it like this. So here are the conditions for a perfect square trinomial, if it fits this. First, it's a trinomial. So you have to look, is it a trinomial? Yes. Are the first and last terms perfect squares? Well, the first is, and the last is. So that one is checked. And then is the middle term twice the product of these square roots? So here we take these square roots, a and b, multiply them together, that's ab, and is this one twice that? It is because of the 2. So we can factor it to look like this. So let's do a couple more examples. Here it's a trinomial, check. Are the first and last perfect squares? Yes, this would be x, and the square root of 49 is 7. Is this middle term twice their product? X times 7 is 7x times 2 is 14x. So yes, that works. So I can write the answer in factored form like this, and because the sign is subtraction, it's going to be subtraction in this problem. And then this is what your answer would be. So again, in the last unit we started with this and we ended up with this. Now we're working backwards using these checklists. Keep this in front of you. Use it as a checklist. All right, is it a trinomial? 1, 2, 3, yes. Are the first and last terms perfect squares? Well, the square root of 4x squared is 2x. The square root of 9 is 3, so check. Is the middle term twice their product? Well, their product, 3 times 2x, is 6x, times 2 is 12x, and there is that 12x. So check. So we can take our sign, put it in the middle, put it in parentheses, and write it as squared. So we went from what we ended up with in the last unit to the original problem. We're working backwards. All right, last example on this one. Is it a trinomial? Check. Are the first and last terms perfect squares? So the square root of 4p squared is 2p, so that is. The square root of 9q squared is 3q, so check on that one. Is the middle term twice their product? So 2p times 3q is 6pq, times 2 is 12, not 10. So it does not fit this pattern. We can always check to see if there's something in common. There isn't. So right now, as far as we know, it is prime. And one last thing, please don't forget to start with that common binomial idea from the last lesson. Always look to see if you can factor out a common binomial before doing anything else. So 2x squared, 12x, and 18, they have 2 in common. So I can start by factoring out that 2. So if I factor out a 2 from the first term, it leaves me x squared. Factor out from the middle, it leaves me 6x. And from the last, it leaves me 9. After I do that, I can check, is it one of the types, the special types? Not the first type, because it's a trinomial, not a binomial. So then look to see if you can factor it as a perfect square trinomial. So I'm going to leave my 2 out here. The first and the last are perfect squares. And the middle, 6x, if I take the product of 3 and x, it's 3x times 2 is 6x. So that last condition is met. So it's addition here, so it's going to be addition here. And then we have to remember to put the squared. I want to just mention that some of you probably will like to write it instead of the squared way, write it as 2 binomials. Either way is fine. If you write it like this, it's a little bit shorter, but this might make more sense to you.